Okay guys, now it's time to have a look at a worked example of a problem to do with perpendicular lines. But before we do that, let's have a look at some of the theory. Let's check it out.
So now it's time to have a look at some of the theory when working with perpendicular lines. Now perpendicular lines are two lines that intersect at right angles, as can be seen on the graph at the left. Now these lines have the following relationship, that is m2 is equal to negative 1 on m1, where m2 is the gradient of the line that you're looking for and m1 is the gradient of the line that you know. For this explanation, m2 will be the gradient of the purple line and m1 will be the gradient of the blue line. Rotating each of the graphs around now, whilst keeping them both at right angles to each other, you can see that the blue line has the equation y equals x and the purple line has the equation y equals negative x. From here we're going to substitute the gradient of the blue line in to prove that the purple line is in fact at right angles to it. So doing this now, you get m2 is equal to negative 1 over 1. And this of course simplifies down to show that the gradient of the purple line is equal to negative 1, which we can in fact see is the case from the circled area of the equation shown at the left. And rotating the lines around now to prove this isn't a once-off case, we get y is equal to 2x and y is equal to negative 1/2 x. And once again substituting in the gradient of the blue line into the equation gets us m2 is equal to negative 1 over 2, telling us that the gradient of the purple line is equal to negative 1/2. And this is once again shown by the circled portion of the equation y is equal to negative 1/2 x. Rotating the graph around again to make the gradient of our blue line negative, you can see that the equation of this line is y is equal to negative 5x. Therefore, substituting into the formula now, you get the gradient of the purple line is equal to negative 1 over negative 5, which of course simplifies down to being positive 1 over 5, which of course is consistent with the equation of the graph that has been shown. Now let's see if this works if the gradient of the blue graph is actually a fraction. Substituting in the gradient value of the blue line being 1/2 into the equation gives us m2 is equal to negative 1 over 1/2. This can be rewritten as negative 1 divided by 1/2. And of course negative 1 as a fraction is the same as saying negative 1 over 1. Now when we divide fractions, we turn the divide symbol into a multiplication one and we flip the second fraction. Multiplying the numerators together and the denominators together, you get m2 is equal to negative 1 times 2 over 1 times 1, which simplifies down to being m2 is equal to negative 2 over 1, which of course is equal to negative 2, as proven once again by the equation of the purple line. So essentially summing up now, if we know the gradient of one line, for example the blue one being negative 3, we can substitute this into the above formula for m1. And this will give us the gradient of the line which is perpendicular to it. In the case of the purple line, this is negative 1/3. Alright, so now it's time to apply what we just learned about perpendicular lines to finding the equation of a straight line. Now this question here says find the equation of a line that is perpendicular to the line with the equation 2x plus 3y plus 5 is equal to 0 and goes through the point 5, 9. Right, now to find out the equation of any line, remember we need to use this formula, y minus y1 is equal to m bracket x minus x1. Remember to write it out every time so that you end up getting to remember it. The next thing, in order to be able to use this equation, is we need to know a point and a gradient. And that's our goal. So let's first of all have a look at this. Do we have a point? Well, yes we do. It's here at 5, 9. Do we actually have a gradient? Well, no, they haven't given it to us directly, but what they have given us is enough information to be able to find it out. So no, the gradient of the line is going to be perpendicular to the equation 2x plus 3y plus 5 is equal to 0. First of all, before I go any further, what I need to do is rearrange it into y equals mx plus c form. Right, so to do that I'm going to minus 2x from both sides, leaving us with 3y plus 5 is equal to negative 2x when these x's cancel out. Right, subtract 5 from both sides now, leaving us with 3y is equal to negative 2x minus 5. And divide both sides by 3, everything by 3 on this side. This cancels out to be y is equal to negative 2x on 3 minus 5 on 3. Now I know that it is perpendicular to this line here. It's perpendicular. Now I know that the gradient of this line is negative 2 on 3, but for it to be perpendicular it needs to be actually at right angles. Now to find out the gradient of a line that is right angles, what we're going to do is we're going to use this formula up here that we've looked at before, which is the gradient of the normal is equal to negative 1 over the original gradient. So let's have a look at that. The gradient of the normal is equal to negative 1 over the original gradient. Alright, well I'm looking for the gradient of the normal or the perpendicular, both mean the same thing. is equal to negative 1 over m1. Now m1 is this gradient here, right in brackets, negative 2 over 3. Okay, so this here is what I actually call a Big Mac fraction. Now you've already seen me describe this before, so what we need to do is we need to just bring the bottom number up the top, and you get negative 1 times 3 over negative 2. Right, that ends up being negative 1 times 3 is negative 3 over negative 2, which of course is equal to 3 over 2. That there is a gradient of the normal, so we're just going to write that over here as 3 over 2. Now I've got my point and my gradient. All I need to do is substitute it into this original formula for a equation of a straight line. So let's do that. Get y minus y1 is equal to m bracket x minus x1. My point is the point 59, and my gradient is equal to 3 over 2. Let's label the point now, x1, y1, and substitute in. So you go y minus y1 being 9 is equal to m being 3 over 2, x minus x1 being 5. Y minus 9 is equal to 3 over 2, x minus 5. Let's just write this out differently again in order to be able to see what's going on. So you go y minus 9 is equal to 3 bracket x minus 5 all over 2. Now I don't like the 2 here because it's an ugly fraction, so what I do is I multiply everything by 2. So I get 2y minus 18 is equal to 3x minus 5, because these two 2's here will cancel each other out. And this all of a sudden looks a whole lot easier. 2y minus 18 is equal to 3x minus 15 when you expand the brackets. And let's rearrange it to make it ax plus by plus c equals 0 form. So negative 3x plus 2y minus 18 is equal to negative 15 when I subtract 3x from both sides. And add 15 to both sides now. Negative 3x plus 2y plus 15 gets us negative 3 is equal to 0. Alright, now let's put this into the form y equals mx plus c. So just write out the equation that I've just come up with here again, plus 2y minus 3 equals 0. And let's rearrange to make it y equals mx plus c. So add 3, negative 3x plus 2y is equal to 3. Add 3x, 2y is equal to 3x plus 3, and divide both sides by 2. Y is equal to 3 over 2x plus 3 over 2. And that's your y equals mx plus c form. Alright, so now it's time once again to press pause and attempt the following question. And remember, as always, press play and check your solutions against mine once you're done. Okay, so before you start, you should always go through and highlight the key information. So we're finding the equation of the line that is perpendicular to the line y is equal to negative 4x plus 5 and goes through the point 5, negative 12. Right, I've written out my formula to find the equation of the line, and I've got my point, it's already been written here at 5, negative 12. And my gradient, well, that's going to be perpendicular to this line. So we haven't actually been given the gradient, but we have been given information to be able to find it. So let's go through and do that. So I know the gradient is perpendicular to the equation y is equal to negative 4x plus 12. Now the gradient of a perpendicular is equal to, the gradient of normal is equal to negative 1 over the original gradient. Alright, let's have a look at my original gradient. I've got the rule y is equal to negative 4x plus 5. So the gradient of the original line is equal to negative 4. So therefore it's going to be equal to negative 1 over negative 4, which is what you've got here, and the two negatives cancel out to become positive 1/4. Alright, so that means my gradient here is actually equal to 1/4. I've rewritten out the formula to find the equation of a straight line, and I've written out my point x1, y1, and the gradient here is being 1/4. Substitute in now, y minus y1 being negative 12 equals 1/4, because that's m, x minus the x1 being 5. Y plus 12 then, because the negatives cancel out, is equal to 1/4 x minus 5. Alright, I've now just moved this part here up on top, because when we multiply that's actually what happens. So you get x minus 5 on 4, and now I multiply both sides by 4 because I don't like the 4 there because it makes it look ugly. So you get 4y plus 48, and the 4's cancel out, is equal to x minus 5. Right, now what we end up doing is we subtract x from both sides. Gives us negative x plus 4y plus 48 is equal to negative 5, because the x's here cancel out. And now we add 5 to both sides. Gets us negative x plus 4y plus 53 is equal to 0 because the 5's once again cancel out. This here is in terms of the ax plus by plus c is equal to 0 form. Now we're going to put it into y equals mx plus c form, so what we're going to do is we've written out the same thing up here again, it's just gone up here. Right, and now I'm going to move everything across and get y on its own, so add x to both sides. The x's here cancel out, leaving us with 4y plus 53 is equal to positive x. Now I'm going to subtract 53 from both sides. These cancel out, leaving us with 4y is equal to x minus 53. And now I'm going to divide both sides by 4 with everything over 4, everything over 4. And remember, the number out the front of the x is actually a 1, so you end up getting 4y over 4 cancels out, leaving us with y is equal to 1/4 x minus 53 on 4. This here is in terms of the y equals mx plus c form.